Dear friends, welcome to the video content on sound. In this content, we will learn about production of sound, propagation of sound, medium of travel, longitudinal waves, characteristics of sound waves, reflection of sound, range of hearing, ultrasound, and structure of human ear. Production of sound. When an object moves to and fro rapidly, it is called oscillations. When the object vibrates, it exerts a force on surrounding medium due to its rapid movements. These forces introduce compressions and rarefactions in the medium which are perceived by us as sounds. Propagation of sound. When an object is vibrating, it also causes the medium to vibrate. The particles of the medium which start vibrating also exert force on adjacent particles which then start vibrating. In this way, the medium transmits vibrations along with it. Note that the vibrating particles do not travel from one place to another. They only affect their adjacent particles. This means sound is propagated as waves, not as particles. Medium of travel. Sound is basically a mechanical wave which depends on motion. Motion exists only in material medium. Hence, it needs some material medium to travel. Since there is no material in vacuum, vibrations cannot be propagated through vacuum. Hence, sound cannot travel through vacuum. Longitudinal waves. Sound propagates as waves caused by compressions and rarefactions in the medium. If we note the direction of oscillations of the medium, it is the same as the direction of propagation of the wave. Such waves are called longitudinal waves. Characteristics of sound waves. Like every wave, sound is characterized by three attributes: frequency, amplitude, and speed. Frequency of a sound wave is the number of compressions or rarefactions per unit time. If we take inverse of frequency, we get the time taken by one oscillation of compression and rarefaction to complete. The compressions and rarefactions produce disturbances in the medium. The magnitude of the disturbance is maximum in compression and minimum in rarefaction. The difference between maximum or minimum disturbance and mean disturbance is called the amplitude of the sound wave. The amplitude determines the loudness of the sound. The propagation of sound in solid medium is faster than in gases. This is primarily because the particles in dense medium are closely packed and can propagate vibrations faster. It is also observed that sound travels faster if the temperature of the medium is higher. Reflection of sound. When sound waves strike a surface, they partly get reflected at an angle equal to the angle of incidence. Human ear cannot clearly differentiate between the two instances of same sound if heard within 0.1 seconds. However, if the reflected sound is heard after a gap of 0.1 second or more, it can be identified as echo. Sometimes, echo is heard only once before it becomes inaudible. But sometimes, due to the presence of walls and ceilings, the multiple reflections take place and produce multiple echoes from various directions. These echoes are called reverberations. Depending on the type of sounds being reflected, it can be pleasing or irritating. Some musical instruments use multiple reflections of sound to generate quality sound which is pleasing to hear. Range of hearing. Although all types of vibrations result in sound, human ears can only perceive sounds with frequency from 20 Hz to 20 kHz. Sounds below 20 Hz are called infrasonic and those above 20 kHz are called ultrasonic. There are some animals who can hear infrasound whereas some can hear ultrasound. Ultrasound. Ultrasound has a useful property that it follows its path correctly even in presence of obstacles. Hence, it can be used to detect cracks or defects in metals. It can be used to see inside the body without any surgical operations by using the reflection to generate internal picture of the body. Sonar or sound navigation and ranging is a technique used to detect underwater objects and topography. It works by sending constant sound waves through water. The reflections are collected and time is measured. The time taken for the sound to reflect back gives the distance between the object and the transmitter or receiver. The high frequency of ultrasound is also used in cleaning inaccessible areas from dirt, grease, etc. The dirt gets loose due to high frequency vibrations and gets cleaned easily. It is also used to break kidney stones whose particles break apart due to ultrasonic vibrations. Structure of human ear. The main function of human ear is to convert pressure variations into electrical signals, which are then sent to the brain, which interprets them as sounds. The outer ear or pinna collects the sound from surroundings and passes it to the eardrum through auditory canal. Eardrum or tympanic membrane is a thin membrane which is very sensitive to pressure changes in the medium. The vibrations in the medium apply forces on the eardrum, which moves inwards with compression and outwards with rarefaction. The three bones in the middle ear amplify the vibrations of the eardrum. These three bones are called malleus, incus, and stapes, also known as hammer, anvil, and stirrup. The amplified vibrations are passed into the inner ear by cochlea. It converts these vibrations into electrical signals. These electric signals are sent to the brain by auditory nerve, and the brain then interprets them as sound. Test yourselves. These are a few questions for you. Please revise the concept by solving them on your own. This content was developed by Akash School Education Project. This project is funded by NMEICT and MHRD Government of India. If you wish to contact us, please mail us at the given email ID. Thank you for watching this content.